Hello, and welcome to our presentation on concussions. This presentation will explore the anatomy of a knockout. Enjoy. This is Kelly. Kelly always wanted to be a star hockey player. He was wearing skates from the moment he could walk. One day, while he was playing a scrimmage with his friends at an outdoor rink, he decided he would try to impress them by playing without his helmet. He was confident he wouldn't get injured and that it was no big deal. Unfortunately, he forgot to take into account the other players' experience with hockey, and he was taken out from behind. He fell hard onto his back, and his head hit the ice and bounced off. He laid there motionless as his friends and teammates gathered around. He was still breathing and had a strong pulse, but he was knocked out cold. Kelly regained consciousness about 30 seconds after impact. He is disorientated and confused. Now let's figure out what has just occurred and what Kelly's recovery looks like.
The human brain is one of the most fascinating organs in the human body. Scientists are discovering new information every day about the brain. The brain is part of the central nervous system. The brain is highly folded and comprised of many gyri and sulci, which are ridges and depressions, respectively. Fun fact, if you were to unfold the human brain, it would cover 1 square meter.
The brain is vital for life and needs to be protected. Luckily, we have the bones of our skull, cerebrospinal fluid, CSF, a blood-brain barrier, and meninges. The CSF prevents the brain from hitting the skull during everyday activities. It keeps it buoyant, and it makes sure gravity doesn't act on the brain, pulling it down through the foramen magnum.
The brain has 4 major regions: the cerebrum, diencephalon, brainstem, and cerebellum. The cerebrum can be divided into 5 lobes: frontal, parietal, occipital, temporal, and deep to the temporal is the insula.
The lobes of the brain are responsible for very important tasks. The frontal is motor and communication, parietal is sensory, occipital, visual, temporal, hearing and smell, insula, consciousness and memory. These will be important when we discuss what happens when there is an impact to the head, especially in Kelly's case. The human body has around 86 billion neurons that have an average of about 7,000 connections. Sounds hard to imagine, right? Well, neuroscientists compare that number of neurons in the human brain to the number of stars in the Milky Way. Fascinating. Typical neurons, or nerve cells, consist of dendrites, a cell body, an axon, and axon terminals. Some neurons have Schwann cells that form the myelin sheath on the axon, which speeds up a nerve impulse. Neurons receive information through their dendrites and send that information down their axons to the axon terminal, where it transmits it across its synapse using neurotransmitters. Neurons have an entire team of glial cells to support, nourish, and protect them. There are 4 types that are specific to the central nervous system. Astrocytes supply nutrients from the blood vessels and form the blood-brain barrier. Microglia are the immune response. Oligodendrocytes generate the myelin sheath. Ependymal cells produce cerebrospinal fluid. Neurons are like a giant web of connection, and if one breaks, the other ones around it break down as well. This is important to remember because in Kelly's case, with the impact that he experienced, his neurons are going to experience some severe trauma that we will discuss in the next few slides.
The brain during an impact. The direct force to Kelly's head causes the brain to twist and turn and bump back and forth into the skull. The brain is protected by cerebrospinal fluid and meninges, which help to absorb minor blows to the head. However, Violent impacts to the head can alter and damage cells, nerve tissues, and chemicals in the brain. This damage caused is dependent upon the area of the brain that was affected during the impact and the intensity of the impact. When the brain strikes the inside of the skull with enough force, it causes millions of neurons to fire at once, which causes the disorientation and confusion. Normally, not this many neurons fire at once, but since they were all forced into firing, this results in massive amounts of ATP being used in the process. Overstimulus from firing neurons can cause the brain to enter distress mode. This can cause a system crash and result in loss of consciousness. This was the case when Kelly hit his head on the ice. After a concussion. The brain is now working twice as hard to repair and protect itself. Microglia and astrocytes activate an inflammatory response to affected cells. This is called neuroinflammation, which has both pro-inflammatory and neuroprotective roles after an impact to the brain. Microglia are the key player in neuroinflammation and can lead to neuronal damage or death, neurobehavioral impairment, and chronic neurodegenerative issues. The impact can also cause the neurons to break and the axons to disconnect from the cell body, causing axonal death. This creates a chain reaction of axonal death with nearby neurons. The dead neurons release neurotransmitters, which triggers an electrical storm in the brain. This electric storm is due to the amount of ATP and neurotransmitters being released into the extracellular fluid. High doses of ATP and neurotransmitters can be detrimental to the brain and to the body. The body is now trying to produce more ATP and reuptake the neurotransmitters before the neurons are damaged beyond repair, as neurotransmitters in high doses cause neuronal death. This is what Kelly's brain is working so hard to repair from his impact.
In order for Kelly to fully recover, it would be advisable for him to stay away from hockey for at least a few weeks to possibly even a month. No special treatment is necessary to facilitate recovery other than just giving his brain time to heal. Keeping mental activities, such as any screen time in front of the computer or TV, video games, or even homework, to a minimum while recovering is also recommended. Just because his symptoms have subsided, this does not mean he is all better and able to play straight away again. If he receives a second concussion before the first one is fully healed, this will only increase the recovery time and will lead to further problems, possibly even permanent brain damage.
Summary. So let's recap everything that we have learned about the brain, neurons, and Kelly's accident. Kelly failed to use his frontal lobe when making the decision to skate without a helmet, thus resulting in a head injury. This injury is what we call a concussion, and in Kelly's case, he knocked himself out because of the impact. From the moment Kelly came into contact with the ice to the moment he was coherent and on the way to the hospital, his brain was suffering from neuronal death, but it was also busy trying to protect itself from further injury. Kelly has a long road to recovery ahead of him. He will have to take some time off of the ice to rest and heal. Unfortunately for Kelly, the only treatment for a concussion is time, but if he follows his recovery plan, he will be able to play hockey again, but this time with proper protective equipment.